Hi everyone, in this video I will be presenting my machine learning project called Smart Recipe Intelligence System. It's a structured learning project where I focused on understanding how different machine learning techniques like supervised, unsupervised and reinforcement learning are combined into a single end-to-end application. Let's walk through the application. The first main entry pointer is the app.py, which runs the Streamlit application. Then the utility modules are the preprocessing.py, which preprocesses the available data into the structured format that I have needed, and the oral cooking.py is the file where the reinforcement learning model is loaded and trained. For model training, I have used two notebooks, the Cuisine Discovery notebook. In this, the supervised machine learning model which finds the patterns and finds the cuisines from the recipes is here. Here I have used two models, LDA and K-means, and the next notebook is the healthy prediction notebook. This is where I have applied the supervised machine learning to predict the health scores, whether it is healthy, moderately healthy or unhealthy of the recipe. And all the model files are stored as a pickle file in the folder models, and the documentation goes to the folder docs. The dataset I have used as a recipe energy dataset, which is a publicly available dataset at Gahel. It contains the recipe title, the ingredients and the directions to cook. Let's move on to the app.py. Here load all modules. This is the function which loads the pre-trained modules to use in the app, and the load or train oral agent. What this function does is, there is already a reinforcement learning agent available. The model loads the agent, or else it would train an agent, and predict the health function, which uses the random forest or SVM to predict whether the recipe is healthy or not. And the predict cuisine, which uses the LDA topic discovery and K-means in order to predict the patterns and the cuisine to which the recipe belongs to. And these are the function for the visualizations I have used. And this main function is it defines the full Streamlit workflow from taking input to displaying the results. The next important file is preprocessing file. Here the clean text function, which takes the textual input of the recipe and it preprocesses the text, it to remove the stop words and lematize. Then the feature extraction. The features I have extracted is the number of ingredients from the text, and the instruction length. Is it baked, fried, grilled, steamed, from using the keywords in the text. And this preprocessed text cuisine is the preprocessing which is done similar to the before, but for the unsupervised model. And create cuisine stopwords. In addition to the English stopwords available, there are necessary for some stopwords in specific to cooking, like salt, cups, teaspoon. It will be available in almost all the recipes, so they are also added as stopwords. And the combined features for health, this combines the already available data frame with the newly created structured features. And calculate a health score. It's a function to calculate the health score, rule-based health score. And the notebook files. The first one is the healthy prediction notebook, which I have used the supervised machine learning techniques. I have used I have used SVM and the Random Forest. First, I have downloaded the record, loaded the record libraries, and then load the data set. and here the pre-processing of the data set is done by using text cleaning, and the feature extraction is done. And here I have assigned the healthiness label by using a rule which I have already said, and based on the score it is classified as healthy, unhealthy and moderately healthy. This is the distribution of the health labels. And the feature engineering is done to find the all these new features. And the train test bed, 80% of the data goes to training and the 20% of data goes to testing. In the first model I have trained is the support vector machine, which classifies by maximizing the margin between the support vectors. And after testing, the accuracy evaluation results is here. The accuracy is 74% and the precision is 73% and the recall is 68%. And here is the confusion matrix. The next model I have used is the random forest classifier. In this model it takes the output from the multiple decision trees, and based on the voting the majority of the output is selected as the random forest output. And here is the evaluation result. The accuracy is pretty low as compared to the before, 67%. The precision is but a bit higher, 78%. And these are the comparative visualization between two models and the confusion matrix of the two models. And the next notebook is Cuisine discovery, where I have implemented the unsupervised algorithm. As I already said, first import the record libraries and then load the data set, then the pre-processing is done. And the first model, LDA topic modeling. Here I have trained with three topics ranges 8, 10 and 12, and I have found that the optimal topic range is 8, and here I have a label based on the cluster keywords available. And after labeling and LDA topic modeling, there are 5 cuisines which I have identified: desserts and baking, salads and fish, Italian style, beverage and fruity, and Asian style. Then the next is the K-means clustering. Here I have clustered the recipes into 12 clusters. First I have tried with various K values in order to find the optimal one. With 8, 10 and 12, I have found that 12 is the most optimal one. And then the labels are also assigned. These are the labels: tropical desserts, main dish, baking and custards. I have assigned labels like that. And here is the visualization. For each of the topic, which of the major ingredient contributed to take this decision is here. And this is the cluster size of K-means of each cluster, and the silhouette plot using cosine similarity is here. Now let's walk through the demo. So this is the application Smart Intelligence System. The first one is the supervised unsupervised learning. In this part I have to give it the recipe title, the ingredients and the cooking direction, which is completely optional one. If we have given the cooking direction, the prediction would be more accurate as compared to not giving. And here we want to choose whether the model is random forest or SVM. After giving the analyze recipe, here is the healthy label prediction from the random forest model. It is predicted as moderately healthy. And the cuisine discovery, by using LDA topic modeling, the cuisine is discovered as creamy casserole, which is right, and the Mediterranean salads may be the next option. And it gives the probability that it belongs to each of the cuisine. And the cluster insects, here this is clustered as the chicken dishes by using the K-means algorithm. These are the keywords which make this decision. And here is the distance from each and every of the clusters. and we could change the model as SVM and then give analyze recipe. The SVM prediction also remains the same as the moderately healthy. Then moving on to the reinforcement learning part. In the reinforcement learning part, I have given the model to take 7 actions, whether to suggest the balanced comfort bowl, bold spice fusion, light fresh plate, hearty grain medley, protein power skillet, or to change the ingredients or change some steps. These are the actions, these are the directions that the model would suggest. So first the available ingredients at home are given here, and the ingredient groups like is it vegetable, grains, it's a completely optional one is given there, and the diet preference as non-veg or veg is given, and the spice preference as mild, medium, hot is given, and the previous recipe profile, which is the previous meal we have eaten, is given, and the estimated nutrition if we have chosen if the suggested action is each of the recipe profile we want to set, and the number of data set recommendations, then we want to give the oral recommendation. So the recommended strategy is the adjust cooking step for faster preparation for the inputs, and here are the each of the reward for that. For the reinforcement learning, I have used a Q learning with the epsilon greedy strategy, which decides whether to explore or exploit further. And from the data set, the suggested recipe is chicken tetasni. I guess it's a Mediterranean recipe. Since we have given the chicken sauce and the cheese, the recipe is suggested, and here is the ingredients and the directions to cook, and other suggestion recipe also here. And this is my project. Thank you.